Hello everyone, welcome back to this Beckhoff TwinCAT 3 motion control series video. And this is the second video talking about MC velocity, how can we adjust the speed on the fly. In the previous video, we discussed how can we use the power override feature. So we can use the override percentage value. We can adjust the move velocity. And in this video, I will talk about the second method. Basic idea, I will use two move velocity. So this two function block can work alternatively. So we can send the command together to this two function block. But this two function block will be only one working in one cycle. So using this way, we can adjust speed. Also, we will use one feature from this move velocity, that is this buffer mode. This will control when we switch over between these two function blocks. How can we deal with the speed? We can abort or we can take over from the first speed to the second speed. Okay? And quickly review, from the previous video, I introduced how can we use the power percentage value, and meantime we set the maximum value to the velocity, and then we can use the power override percentage value adjust the move velocity actual speed. If we quickly recall from the previous video, this is my target, the actual target. I sent 10 millimeter per second, and this value will over this maximum value, this maximum velocity. We arbitrarily set of 500. This 500 is an arbitrary value. In actual case, you need to set the maximum value higher than any command you need to send to the velocity. And then this maximum value need to be set to the MC velocity. We can go to the single axis LD and go to the move velocity. We set this maximum value at here. Then we will use the percentage override, the MC power, this override. This is the percentage value from 0 to 100. Okay? And this override value times to this maximum value here. And then the result will send to the MC velocity, the axis, control the velocity. This is the case fit for the very simple axis control. For example, if you are using the PID equation control, connect to a servo motor or a VFD. To adjust the velocity for the servo or the VFD, we can use this MC velocity. But for adjusting the speed of velocity on the fly, so we can use this override, this function. However, this method 1 could be a slightly issue that because this MC power override will override all the speed control command for all the motion control. For example, other than the move velocity, we also have a positioning control, move relative, and move absolute. When you switch from the velocity control mode to a position control mode, you need to take off that override function. So send override to 100%, and then this velocity for the relative and the absolute will be available purely for this command directly here. Otherwise, that percentage value will be effective for all the function blocks here. So you need to use the simple logic, control the override percentage value, this percentage value. But when you switch to the position control, this override, basically you need to control to 100%. Okay? So this is method 1. The method 2, the basic idea, we will use the two move velocity. So this is the first one. This is instant dB behind. We will create the move velocity 2. So we will create a second move velocity here. The basic idea, we will switch over this trigger signal back and forth. And the command we will directly send to this 2. So let me quickly show how can we program this. Okay? So let me log out. Firstly, let me create a second the MC velocity, this instant dB call. So my instant, this variable is declared under this dvl underscore SA. Okay, the first instant MC move velocity is this, FV SA underscore move velocity 1. Then we will declare the move velocity 2. Its data type is MC underscore move velocity. Also for other variables, Also for other variables here. So I will use the similar way. For this command, they all named 1, command 1, status 1. We will create the command 2, status 2. Okay, this is a very simple idea. So now if I copy and paste, so now I just copy this. So we will change this move velocity to velocity 2. Okay, and those variables I will change from command 1 to command 2 because I already declared those variables. Those variables we can go to the gval_sa and add here for the command, they are here, velocity command 2. And for the status, they are status velocity status 2. Okay, to reveal how and create those structure. So this three type here, you can review a video before. I will show the link below this video. Okay, this is a structure MC_command. You can also watch this and create your own. Okay, and the structure MC status, they are this status. Okay. And now I'm gonna go to here and change all those commands to 2. Okay, and our actual command, I will replace this to the original. So firstly, this percentage value will come out. And this velocity, that's the first command, this velocity 1, that command. Okay. Velocity 1, I will return here. And for the second one, that is a velocity command 2. Okay. Change to 2. So here, if we are using only one move velocity, so that trigger signal will be only available while this BZ is off. And when the acceleration deceleration is low and very slow, so when we trigger the first command is towards to the target, but before we reach to the first command, if we change this as a velocity set point already, if we change this velocity command already, so that new command won't be available till this BZ got off. That BZ got off means this access reached to the first command, and then you trigger the second command again. That time the second speed command will be transferred to the access. That is not changing on the fly, right? And then now we are using 2 commands. So once we switch over 1, 2, 2, 1, switch over. So the new command, once it's got triggered, it will take over the first command and it will run the second. And when the third command trigger, so the second will abort and run the third one. But the example here, we only use 2. They will switch over back and forth. But one thing we need to take care here, so when we switch over the command, when they take over each other, how can we deal with the speed from the first one to the second one? So that will talk about the buffer mode. So now let's go to Beckhoff information system. From the MC_move velocity, let's go to the buffer mode explanation here. The key idea is abort. Once we trigger another command, the previous one will be abort. But the speed, how can we take over the speed from the previous one? So let's go to the MC buffer mode. We can type in the word to the MC buffer mode. And those modes, from this diagram, we can see which mode we are going to control the access. To change this velocity on the fly, basically we will use these 2 methods, blending previous or blending next. Usually I will use this one, blending next. So we can see the first one is running. Once we got the second trigger, second command, so the first one will be abort here and the second one will take over the speed. So the new speed will be the second, the next command it got triggered. Okay, so keep in mind, this 2 move velocity function block, we need to change that buffer mode to blending next or this blending previous. while it's changing on the fly, actually this two command, it's hard to see the difference. So the key idea is we do not need to wait the first one finish. We just take over from the previous one and let this new one enable. Okay, so let's go back to the program here, which means this buffer mode, we need to change this buffer mode. We can type in this MC blending next. Okay, so we can change this buffer mode here. Okay, here. Okay, we are using these two function blocks. Command 2, this velocity set point actually could be the same as this. Actually, when we send the command, the same command will send to this two function block. The actual speed while it's changing, so it depends on which command we are triggering. The second command can be same as this one, so we can do a very simple logic outside here. Go back at the top of here. So the second command can be equal to the first one. So okay, so this command can be the main command. And which function block is working, that depends on the trigger command. This trigger command. Okay, so I'm gonna delete this and prepare the next one. So from this watch list, I can prepare the next trigger. Okay, firstly, I'm gonna log in. Okay, and then drag this command. This is the second one. Drag this second command to here. This time we can see once I send a new value here, once I toggle them, so we can see the actual command is working. So now we log in the program and let me power on. And let me power up this access. And in the meantime, this override we can set 100. Okay. And now we power up the access. The override I send to 100. This 100 can be stay here. And now this target is 10 at first. So 10 send both. It depends on which one I trigger. Okay, now let me trigger the first one. And now it's running 10. So let me trigger a higher, so 100. So send to 100. Let me trigger the second one. So we can see it's towards to 100. And now if before it reaches to 100, I send to 10 and trigger the first one. Then before it reaches to 100, it go back to 10. And before it reaches to 10, let me trigger a new value, 200. And let me trigger the next one. So we can see it ramp up. And before it reaches to 200, let me trigger the new command. So basic idea, trigger them back and forth. For example, let's trigger a 10, back to 10. So we can see before it reaches to 200, it can go back to 10. We do not need to first finish the first one and then switch to the next command, right? So it's changing on the fly. 300 this time. So it's towards to 300. And before it reaches to 300, we can send to a very low speed, for example 10. Prepare the next trigger. So now it's slowed down. We do not need to go to 300 first. So it directly go to 10. Okay. So it go to 10. Okay, this is the key idea. This two function block trigger can be toggled and alternative back and forth. And command speed can be the same. The key things, they cannot turn on at the same time. So they need to take over back and forth. Because if this first one has been run, the next one trigger, the first one will be abort. And then using this buffer mode, this blending next, that will smooth take over the first command and the actual speed. And the next one will take over that command. And when we trigger it again, so this one will be abort and the new command will take over. This back and forth. Using this way, two function block, we can toggle the command and our new command can be sent to the axis. Using this way, this speed can be sent to the axis and the speed velocity can be changed on the fly. So toggle this two command. How can we program a very simple logic to allow these two commands can be switched over back and forth, right? Keep in mind this execute, it need to be from off to on. It need a rising edge. This two execute need to be on and off, just toggle. The basic idea we can do, we can create one variable, make it this one variable one cycle on, one cycle off. So let me show how can we implement this simple logic. Firstly, let me log out. Let me stop this access first. Shut down the power. And please follow me. Let's go to the GVL_SA. Log out. Let's declare three variables here. So first one bool signal, B, on off cyclic. So this one will be the row one cycle on, one cycle off. Okay, that's the bool. And to program the on and off logic, I also need one integer value to facilitate that. This is my programming style. So you can also use other strategy or other programming way. Personally, I will prefer use another one integer to calculate that, so we can toggle this bool. And I'm going to declare one integer value. I will name integer on off cyclic. Okay, and this variable, that is the integer. Okay, and other than this, I'm gonna declare another variable, that's the enable variable, because once the CPU start to run and once this bool toggling this variable is working, so it will on off like this. So we definitely need another enable signal. Once it's on, so it will deliver this on off trigger to the execute command. And once I enable turn off, it will disable. So we need another command. For example, we can name that bool velocity enable. Okay, very simple. So this is the bool. Okay, and then to program that toggle, so keep in mind that logic, this is our core, the motion control function. So I will program some logic at here and at here. So firstly, so time being, I will directly copy the code at here. Okay, this is the top area. And the bottom area, that's this logic. As we can see, I'm using this bool logic and this integer. They work together to implement, allow this bool on off cyclic, this variable can turn off, turn on every cycle. So for example, the first cycle, that's the off, right? And this integer is the 0. And once it run to here, it's not equal to 2. So it will jump here. So add 1. Next cycle, once this integer value equal to 1, we will turn on this bool. And that time the integer is equal to 1. Okay, this is the second cycle. At the bottom of the second cycle, we will add 1 to this integer. That time this integer equal to 2. And the third cycle we run here, we will turn off this bool. So the previous cycle, that bool was on, now is off. So it run here is not equal to 1. Once it's reached here, the integer equal to 2. We zero this integer. We zero this integer. And once it reach here, the integer equal to 1. And once it reach to this cycle again, so equal to 1, it will turn on. So, and then next cycle, this bool will turn off. So using this two area logic allows this bool, this variable, turn on one cycle, and the next cycle, it will turn off. This on, off. So using this on, off, it can be the one of the condition to trigger this command. Okay? And to trigger this command, we need another logic. Meantime, don't forget, we need to involve the halt command and the stop command. So when the halt or the stop, they are one of them, they are on, we cannot send the command to the move velocity. Otherwise, if the on-off still trigger in this execute, our error list, you will see a bunch of error there while you are holding or stop the access. If that time you still trigger that move velocity, we will got a bunch of fault. That means that when the halt command and stop command they are on, we will disable the trigger, disable the on command signal to the velocity trigger. In the meantime, we will also use one feedback from the first one, the function block, this busy, which means if this first function block is not busy, we will trigger this. If the first command has been busy, so we will turn to the next one, trigger the next one. Okay, this is our idea, using this first one busy feedback and control which function block we need to trigger. Okay, so let's go back. Before this logic here, so the first function block command is this. So I'm gonna copy this and let's go to the program here. This one. So this one will controlled by, firstly, I will use the GVL, that enable signal. Firstly, I will use the GVL underscore SA dot enable signal. We just declared that we lost the update enable. Okay, and the logic we will use AND, the AND logic. So and that toggle switch, this toggle switch here. Okay, and also as I introduced, so to trigger the first function block, if that first function block is not at busy, so we can trigger that. So we will use the not busy signal. That busy signal, that is the output from this MC velocity. That is this variable. Okay, I'm gonna copy that. Busy signal. And other than that, we will also need to consider and the halt and the stop was not on. So the first one we will use not the halt on. So the halt command is this. So the halt command should be on, should not be on. So this one. And the next logic, and so the stop command should not be on. So the stop command is this. Okay, copy. Go back here and not on. Okay, and this is our basic logic to control the trigger command for the first function block. And here, this logic is too long. So personally, I will prefer from here, we can do the second line. So we can see this is enable signal, and this is the on-off logic is always on-off working there. And this is the command, the condition to control this also. And this is enable also. So the halt shouldn't be on and the stop shouldn't be on. Okay, and keep in mind. And this is the first one. And second one will be the similar idea. So firstly, the second function block command, that is the command 2. Okay, we copy and paste here. And the same idea, we will use this update enable. Okay, and same thing, and this toggle command. And then, so when we need to trigger the second one, that time the first one, the first function block, well, is busy. So we will use busy direct. Okay, so see this difference. So this two command won't be turned on at the same time. So this busy will control go this way or go this way. It won't be turned on at the same time. Okay, and for those halt and the stop, the same idea. We'll use that here. Okay, copy to here. Okay, see this difference. And also these two command, the speed command for both function block, they are the same. So we will use this command 1 at this watch list here. Okay, so now let me log in the logic. Firstly, let's verify this on-off signal. So we can see it's changing on-off, on-off. Actually, it's changing very fast because one cycle on, one cycle off. And our cycle that come from this PLC task. And is running 10 milliseconds as 1 cycle. So actually it's turning on and off very fast, 1 cycle on, 1 cycle off. And now the function block, we haven't triggered that, so this busy is off, and we haven't enabled that. Now let me enable. So once I enable, so this command 10 will start to work. Okay, firstly, let me power on the access. Okay, firstly, let me double check if I power on this access. Okay, let me power on, and in the meantime, this override is 100%. Okay, I power on the access. Okay. And once I enable this, so this on-off will deliver to this two trigger, depends on the condition I hear. Okay, so I'm gonna enable. So we can see once I enable, this 10 will deliver to this two function block. And we can see this two trigger command, they are toggling there. And now if I go to the function block there, so we can see on, off, they are toggling alternatively. Okay? And we are sending the same speed now. So now if I change in this speed, so firstly let me change to 300, and then we can see the axis towards to 300 is ramp up. But before it reaches to 300, let me change to a lower speed, so we can see the speed will directly go to 200. We can see the speed will direct to 200. And in the meantime, we can see the busy signal from this two function block. The busy also, they are changing over. Okay? So now, if I send 300, okay? So we can see the 300 is enabled, and the axis is ramping up. It's towards to the 300. But before it reaches to 300, I can send a new command, 20. So we can see the axis will not reach to 300. It will directly go to 20. It do not need to reach 300 at first and then go back to 20. So we can change the speed up and slow it down. So the actual command to the axis can change on the fly. 100, 100, ramp up, and before reach 100, I can send 10. Let it slow down. And even now, I can send 0 and almost stop the access. But after that, I can send a new command. So, and then it can ramp up. Okay, run 100. Okay, run 100. And ramp up. Meantime, we can see this busy and active, they are changing over, toggling, and alternatively. Okay, alright, this is the key idea for implementing this two function block to allow this velocity can be changed on the fly. Okay, let's do a quick summary. So let me firstly stop this access. Okay, once I turn on the stop the access. So if we go back to here, so we can see this execute, this command won't be on because we are using this logic here. Stop. When the stop on, we won't send the new command to here. And the key idea, the logic we are programming here. So we are using one toggle signal and also use this simple logic. You can also involve other conditions, right? But key idea, so to trigger the first one, if the first function block is not busy, then we trigger the first one. But if the first function block has been busy, so here, if the first one is busy now, so we will trigger the second one. The second one will take over the first one. And meantime, we are using the blending next, that buffer mode. So that can allow the speed can take over smoothly. And keep in mind, so the toggle signal, we are using the simple logic. One part is at here, one part is at here. Keep in mind, this two part, the first part should be at the top of the logic. And this area should be at the very bottom of the logic. Okay, and your application should be in the center. So using this bool and this integer, we can implement, allow this bool, this variable can be on and off each cycle. This is the main topic for today, for changing the velocity on the fly. So using two function block and using this logic, so this two command can trigger this two function block alternatively, so they can work and take over each other. Alright, that's it for today. Thank you for watching.
Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.